Now we'll go into more detail and understand what is this x-axis and what is the z-axis. So whenever you are having two axes, they are going to intersect, and the point of intersection we will say it as the origin, or that is from where we are going to measure the distances, or we are going to specify the coordinate system. Otherwise, if you are not fixing the origin, then there is no meaning for the coordinate system. So for example, let us say that you are having the workpiece, this is the end face of the workpiece, somewhere inside I am taking the origin. Now where should this origin lie? Origin will lie along the intersection of the x and z axis, or we can say that x axis and z axis are starting from the origin. So here it will be 0 0 coordinates, and in this direction, that is away from the chuck, that is the positive z axis. Away from the machine spindle, we will say that that is the positive direction of the x axis. Now what is the z coordinate represents here? So you are having this particular end surface. Now let us say that the surface here is at a distance of 10 millimeter from the origin. So if you are taking a point here, that along the z axis it is 10 millimeter, so z coordinate will be 10. Now what is the x coordinate? So x coordinate, as I told earlier, it is equal to the diameter at that particular point, or it is 2 times the radius. So now what is the radius at this particular point? The radius is 0, so diameter also is equal to 0. So the coordinates will be 0, 10, 0, plus 10. Now if you take a point over here, so let us say that, so from here to here it is 10, so from here to here we will say that is also equal to 10. So if you say from here to here the distance is 10, which means the diameter of the workpiece is 20 millimeter. So this radius is 10, this radius is 10, so this point the diameter is 20. So what is the x coordinate over here? So x coordinate is equal to the diameter at that particular point. So at this particular point the diameter is 20, or in other words we can say from here to here the distance is 10, so 2 times the distance, that is 2 into 10, that is equal to 20 is the x coordinate. Then what is the z coordinate? Z coordinate is from here to here, we know it is 10. Then at this particular point the diameter is 20, so it is 20, 10. That is the coordinate at this particular point. So we have to be very careful about the x and z coordinates in the CNC lathe system. So now in this particular case, what we are doing, we are having the origin at the end surface of the workpiece. So earlier we are having the origin at the somewhere on the inside here. Here we are having the origin somewhere at the end. So from this we should be very clear that we can have the origin anywhere. We can have the origin of the workpiece anywhere. We can be having on the inside of the workpiece, at the end face of the workpiece, or we can say that it can be outside the workpiece also is allowed. So we can fix the origin of our coordinate system using which we are finding the coordinates anywhere along the spindle axis or anywhere within the particular plane. So that is allowed. So where we want to fix the origin, it is dependent on the user, and then based on the origin he is fixing, he has to find out the coordinates of all the points of interest so that he is able to move the tool along the required profile. So now we will see a small 2 points A and B. We will see their coordinates and we will try to find out the different distances. Now you are having the workpiece here. Then you are having 2 points A and B. Their coordinates are given as 10, 15. The coordinates of B are 30, 40. So whatever the first value is there, that is the x coordinate. Whatever the second one is there, that is the z coordinate here. Let us take like that. So x is 10 here and z is 15. Here x is 30, z is 40. Now what is this 10? 10 is at this particular point the diameter will be 10. Means, or from here to here the distance will be 5 units or 5 millimeter. Now 15 is the z coordinate. So from here to here the distance is 15 millimeter. If you go over here, then x is 30, which means the diameter at this point is 30, or the radius from here to here, that will be 15 millimeter. Then z is 40, which means from here to here it is 40 millimeter. So divide the distance between the 2 points. So along the x direction, the distance is So here if you are taking a vernier and if you are trying to measure, then from here to here what will be the distance, that is the radial distance. So from here to here it is 5, from here to here it is 15, so 15 minus 5, that will be equal to 10 millimeter will be the distance here. Or in other words you can say 30 minus 10, that is 20, that is the diameter value, change in diameter divided by 2, that is equal to 10. So this distance will be equal to 10. In this particular z direction, what is the distance between the 2 points? The distance between the 2 points here is 40 minus 15, that is 25 millimeter. So that is the x coordinate and the z coordinate values for a CNC lathe system. So let us say you are having origin here, that is 0, 0. So you are having the z axis, you are having the x axis. So let us say that this is the x coordinate and this is the z coordinate. Again here you are having some x coordinate that is missing and you are having the z coordinate. Now you are having a point A whose coordinates are 10, 15 and you are having a B and to B. Now the line joining them is at an angle of 45 degrees. Now what will be the coordinates of point B? So if you want to find out the coordinates of the point B, we will try to do it with a triangle. So this is B, this will be A, 30 millimeter. Why it is 30? So here it is 45 and here it is 15, so that difference will be 30 millimeter. So we are having point A to B, which is at an angle of 45 degrees to the horizontal. So along this horizontal direction, we are having the distance between the 2 points as 30 millimeters. Then you are having a 45 degree, so this is a right angle triangle. If this is 30, so the other side this also will be equal to 30. Now but whatever the coordinate value of B is here, the x coordinate value, that represents the diameter at this particular point. So if this is 30, that will be on the radius. So we have to add 2 times, so 30 into 2. Then we have to add the diameter at this particular point, that is 10. So 30 into 2 plus 10, that is equal to 70 millimeter will be the coordinate of x coordinate of B. Or if we want to find out everything in terms of the radius, then we can do like that. So from here to here the radial distance will be equal to 5. Then from here to here the radial distance will be equal to 30. 30 plus 5 is 35. That is the radial distance from here to B. So but x coordinate represents the diameter. So 35 into 2, that is equal to 70 is the x coordinate of B for this particular point. So in this way it is important to calculate the different coordinates of the profiles that are given, so that we are able to control the movement of the tool from one point to the another point.